So analog baseband circuitry producing the quadrature signal in the transmitter exhibit DC offset. You know DC means it will going to shift your signal by a constant value of voltage. See here, the in phase component shifted by VOS1 and the quadrature phase component is shifted by VOS2. Where VOS1 and VOS2 denote the total offset which refer to your input. Offset means you know from the base level how much the signal is being shifted. If you if you put a plus sign means it is going to shift upwards. If it is minus means you are going to shift downwards. So this subconverter will have a total fraction of the unmodulated carrier power. So this is your when you expand this using when you expand the terms and when you simplify the terms, you get this A of t cos omega ct plus phi, plus you have the effect of the DC offset terms. One is additive, one is subtractive. So effectively, we can see what is the unmodulated carrier power we have in the signal. So we call it as carrier leakage. So the shifting DC offset in your transmitter will result in carrier leakage, and the carrier leakage is given by how much volts the carrier is shifted divided by the power of your actual signal. So it is going to be RMS, right? So root of VOS1 square plus root of VOS2 square divided by root of A square of T. So A is going to be your actual signal, and this is going to be the DC offsets which are present as a part of your signal. So this will lead to two adverse effects. First thing, it will change your signal constellation. As I told you, signal constellation chart shifting. When the signal constellation starts shifting, receiver will have issues in decoding your signal. And next one, we measure the effectiveness of system using what is called as error vector magnitude, or you call it as EVM. So, and it will start increasing the EVM value. Ideally, error vector magnitude value has to be zero, but practically EVM value will be there and it has to be very, very small. Second effect, the output power must be varied across a wide range by amplifying the amplitude of baseband signal. So since you're using a power amplifier, so the power amplifier should have a very wide range so that the entire input signal is effectively amplified for transmission. So that power amplifier requirement has to be properly decided because that has to amplify the entire range of your baseband signal. So CDMA mobiles must lower the transmitted power as they come close to the base station to avoid near power effect. That's what they say. Whenever you are very close to the base station, more power is not required. So they start lowering down the power transmitted and power received. So that is going to be called as near power effect. The base station will always calculate the power received from mobile station, and it will request the mobile station to adjust the transmitted power so it can minimize its requirement. When there is a shortest distance, there is going to be a carrier leakage. So carrier leakage means the carrier power dominates, making it difficult to measure the actual signal power. So it becomes very difficult, and when the signal power measurement is going to be difficult, PA cannot work effectively. Because of this near power effect, there is a chance that carrier leakage will happen and the power amplifier will not